Welcome to the Reimagine Mobility Podcast. I'm here today with John Fuerst of Tula. John, thanks for joining me today. You got a rich history. You work with a very interesting company that plays a very important role in the mobility space, not just passenger vehicle, but across different segments of the mobility space. We're going to start out with John. Introduce yourself, a little bit of your background, and then certainly for many people who may not know what Tula does, explain what it is that Tula does, and we'll take it from there and start together down this journey of reimagining mobility.
All right, great. Well, first of all, thanks for having me on to have this conversation with you, Stephan. Been a pleasure getting to know you over the last couple of years, and happy to be with you here now. So my background is always been automotive. Joined General Motors 4 decades ago, and since then spent most of my time at GM, then Delphi, Powertrain, starting in engineering, but later finance, marketing, and some general management, and got to run the diesel business at Delphi for a little while. But anyway, more recently, maybe more interestingly in some ways, I joined Tula Technology in 2016, so that's 7 years ago. And Tula Technology is a California-based, Silicon Valley-based startup in the automotive, but also in the software and control space. And we've developed a couple technologies, Dynamic Skip Fire one and Dynamic Motor Drive another, that have interesting ability to increase efficiency, essentially through software and calibration only. We're not focusing on hardware. In fact, we're not so much focusing on software per se, but rather intellectual property creation, which enables higher efficiency in energy conversion. So that's what I've been up to and enjoying it.
Excellent. So let's jump right in it. The other day I read, and I forgot where it was, but somebody made the statement that, and I'm paraphrasing, we oftentimes forget how important software is for the performance of batteries. You just alluded, you help with your software, within your intellectual property, make vehicles, ICE vehicles, EV vehicles, more efficient. John, in your history that is very rich with powertrain, as you just explained to the listener viewers, is this something that's new, how important software is? Or maybe first of all, do you agree with this statement? And then second of all, is this only something that recently has come to the surface? Have you always believed in it? And where do you see it going?
Okay. Well, yeah, I think, what software is doing for us, with us, together with innovation or transportation technology, of course it goes back 50 years, let's say. More recently, and of course, fashions come and go, and now many of us, if not all of us, are saying, software-defined vehicle. And, first of all, what I think that means is creating hardware that is flexibly responsive to alternative control strategies. When you build, in the end, our physical experience is happening with physical stuff, which software is not. But then, so why is software important? Well, because software allows us to design, create, and have bits of hardware, like our smartphone, right? You could say it's just a brick, but of course it's not. You get the control, the software, and the zeros and ones moving around, and it's massively, massively flexible and delivers all kinds of incredible different experience and value and entertainment and all of that. And yeah, it's happening because of the software, but it's enabled because the hardware, the microcontroller, etc., all of that is designed to respond to this infinitely flexible acceptance of software that enables things to happen in complex and really, satisfying ways. So it's totally different than what we were doing with, in the 70s with emission control and, closed loop, 3-way catalysis and stuff like that. And yeah, there was software and calibration and you know, PI control. But the more we've been able to create hardware that's responsive to complex software, the more we've been able to do with it. So, so maybe that was your first question. And, you know, at Tula, our let's say Tula 1.0 technology, let me say it that way, is what we call dynamic skip fire, which is cylinder deactivation controls at individual cylinder level on a combustion event by combustion event basis. And we put that into production with General Motors. General Motors calls it dynamic fuel management, and they've got that on V8 engines across many vehicles. And, you know, by all accounts, has had a nice implementation there, between 2 and 3 million vehicles already on the road, with the GM DFM, you know, whose core, let's say, core control is our dynamic skip fire. And that implementation, of course, requires cylinder deactivation hardware at some hardware cost, and that's the hardware which then can respond to a sophisticated combustion event by combustion event control, which reduces fuel consumption by reducing pumping losses, et cetera, et cetera. So, so that's, let's say, the Tula 1.0, and Tula 2.0 now has been what we've been doing in the electrification space.
So, John, if we take the approach of Tula 1.0, 1.2, let's for a moment envision mobility, reimagine mobility. I'm going to say Tula 5.0 is to something you guys could look at to say, I could come to you, download a certain set of an app. Let's call it an app, right? So everybody understands. I download the app and I flash it in my software-defined vehicle, and now suddenly my vehicle is more efficient. Am I crazy? Am I envision the mobility or reimagine mobility within the realm of possibilities, or what do you see?
Yeah. Well, first of all, I'm glad you said 5.0. So that means we got a few generations, you know, between today and what you have in mind there. So no, I like the question. But I think to come back to where we are today, what we're doing right now with dynamic motor drive for e-drive application, we're doing a similar pulse-based, higher fuel, electrical fuel efficiency strategy that improves e-drive efficiency by 1 to 2%, you know, depending on architecture and topology, et cetera. But without just going into that in detail right now and trying to really think about the future and, you know, downloading and flashing in more efficiency. Let's just insist on that question. I think that's difficult and a little bit far away. I think when we first talked about software-defined vehicle, and I talked about a smartphone, or we're talking about how the vehicle responds to the driver, and a driver being able to get in and control, you know, HVAC and infotainment and seat and heating and all of that sort of human-machine interface, where, you know, the way the vehicle responds to the driver's input, the gain on the knobs, and how you interact with the vehicle. I think there's enormous flexibility on how the car can be programmed. And I can see, yes, you can flash that and do that over the air and do exciting things that people say, well, okay, it's much more my vehicle, and I can make it for me, and I can select different ways of experiencing the vehicle when I'm in it. You know, going back now though to Tula, and what we're trying to do is energy efficiency when we're transforming, you know, energy and carriers, taking fuel into a heat engine and making work, or taking electricity and putting it through an e-machine and creating work. Then it gets maybe a little bit more constrained, let's say, because you know, those are much more, let's say, focused and specifically optimized systems, already trying to be as efficient as you can. And a lot of the things we do to get efficiency, whether it's combustion or in e-drive, you know, is constrained by the fact that we're creating motive torque for a vehicle, and the safety considerations, are paramount there. And so, the likelihood that we can do a lot of things to say, oh, we've got a new little approach we can flash in to get a little more efficiency out. I think our industry probably is still at the point where you probably want to try that out pretty thoroughly on the road and do some homologation, a little bit of validation before you do those things that impact how the vehicle is moving in space, and not just about the experience of the human in the car. But we're certainly going in that direction. And I'll give as an example, our dynamic motor drive for e-drive system efficiency improvement. There's no question that some versions of it can be implemented with little or no hardware change at all. So in terms of the principle of software being able to cause an existing set of hardware to give a new experience, that's definitely there in what we're doing right now with dynamic motor drive. And that, with a essentially pure software and calibration approach, you can tease out meaningful amount of incremental efficiency. You still want to do proper validation, but in the end, it becomes essentially a pure software and cal revision to a complex physical system where you actually get a different physical result in terms of energy transformation from electricity to kinetic movement of a vehicle.
All right. You're talking a lot, and we're talking a lot in efficiency, right? Both traditional ICE and certainly EVs, and this is where you guys are in. John, with your history and your experience in the automotive space, in the mobility space, what do you think are the three things that maybe we as an industry are not yet focused on enough, right? And what I mean with that is, at AVL, we look heavily at thermal management when we look at an EV. How can we optimize it, right? How can you optimize all the electrical consumers, for example, in a vehicle? And again, in many cases, with less hardware changes, but more software and software strategy, address the efficiency, right? The efficiency usage. And then clearly with system architecture and how to better, smarter, whatever, architect an EV for heating, cooling, whatever it might be. What is your perspective on where the industry has still room to grow or room to refocus and should be focused?
I think I would like to say that the industry is doing a beginning of a good transition to more flexibility and more variety, even in the face of the economic financial constraints and challenges of making the move that the industry is making right now. The electrification, wave or trend or whatever it is over the last few years, it's really accelerated. And when I look around the industry and I see the different solutions that are out there, and recognizing what it costs to implement that kind of variety, at the same time you're keeping a lot of other stuff going, I would say that's something I've always thought. You don't want to pretend that you know enough to say, this is what we're going to do and this is our direction. And it's nice to have focus. It's nice to, pick a path and follow your path, but, stuff's changing and things are moving all the time. So, I think working on that balance between, spreading your bets, recognizing that a little bit of variety is probably a good idea because, some shit's going to happen that you don't predict or expect. And you want to hedge your bets a little bit. You got to do something. You got to make commitments, and factories and capitalizing vehicles is wildly expensive, right? So you got to make serious decisions and say, okay, we're going to do this. But you also got to do a little bit of that as well. And, one example, that's near and dear to Tula's heart is what's happening with motor topology, with the movement from, let's say, the beginnings here of high volume EV production is pretty much all permanent magnets. And and rare earth metals are great for what they do for temperature and delivering power density and durability. It's all great, and that's fine. On the other hand, you've got significant environmental, headwinds and costs to be incurred there. And what I see in the industry moving towards wound rotor machines, what Renault, BMW, others have done already in production, and what we at Tula see across the industry from tier ones and OEs is that the wound rotor technology, which maybe had some catching up to do, and there's challenges there too, but in terms of efficiency comparison, we see the efficiency getting quite similar. And, of course, from the Tula perspective, we like the wound rotor because our DMD technology delivers 2 to 3 times as much benefit to a wound rotor machine as a permanent magnet machine. And so we're cheering on the wound rotor. But, having the alternatives out there and the guys that are working on axial flux, that are looking at different, battery chemistries, it's really expensive to spread your bets, but I think, flexibility and having some variety is critical, especially now that, we're only a few years, really, call it a decade, in electrification. And I think there's just so much to be learned, right? We polished the combustion engine for 100 years. And yeah, the e-machines have been around 100 years too, but not in the way we're using them now. So for me, I think to remind ourselves that there's so much we don't still know, and we need to be ready for surprises.
Yeah, I think that's a very, very good point. I agree with you. So if we take that theme and kind of carry it on and say, then what, in your opinion, John, are the 2 main areas where you believe over the next 5 years most innovation will happen? Is it e-motor, as you just mentioned? Is it battery chemistry, from going to solid state, for example, and being able to manufacture those at scale? Is it more of a complete electrified propulsion system? Is it, again, going back to software? We can talk about propulsion. We can talk about the complete car. Up to what are the 1 or 2 main things you see happening over the next, let's say, 5 years?
Right. Yeah. But as I listened to your question, I wrote a couple things down. The first thing that comes to my mind is that it's often easiest, I think, to think that, the most opportunity and the most potential for change and everything else is probably going to happen in areas you don't know that much about. So as you asked the question, I was thinking to myself, holy cow, there's all kinds of ways to make that battery, and a lot of things are happening in battery space, but as it's not my space, I don't know. But from my distance, I look over there and say, holy cow, there's all kinds of stuff in the pipeline. It looks super exciting over there. Okay, but I don't know batteries, so I'm going to stop on batteries there. I'd say in the rest of, let's say, e-propulsion driveline, there's been a lot of time spent, a lot of effort spent there, and I think that one of the areas where I think we're probably going to get some good surprises is on the manufacturing side. I think that when we look at whether it's, let's just say, axial flux or IPM or wound rotor, those types of technologies, part of the challenges, I think, axial or wound rotor, maybe, let's say, are manufacturing challenges. Product design, product innovation is important, but a lot of the things that kind of finally hit the market and are successful, they're very often a little bit oldish ideas that everybody knew was a bright idea, but you couldn't do it. And somebody figured out how to do it. And so for me, the manufacturing side is the area where I think probably doesn't get as much credit as it should in terms of, why did something finally hit the market and really kill it? I think the manufacturing side is, and maybe that's because where I started, I guess, way back long ago. So, that's part of it. But to specify the manufacturing of a product, always involves more parameters the specification of the product, right? I guess that's kind of natural. So I think manufacturing is a big deal. And coming back to the beginning of our discussion, the software topic, software-defined hardware, maybe that's a way to say it, right? The hardware is designed in order to be able to deliver, a kaleidoscope of resulting function depending on the software that tells it how to act, how to behave.
Right. I think you're making a very good point. Everybody talks about software and the software-defined vehicle, but software by itself is not going to do anything. So the hardware, as much as we seem to give it sort of a reduced role or reduced importance, to me is as important, if not more important, than the software itself, because the greatest software without hardware is not going to be anything.
Right. Yeah. I think there's just one more word there on hardware and software. There's a virtuous circle there, right? Because the more the hardware is defined in a way that the software can control it differently, and generally the more electrified the hardware function is, the more the software can control it, right? Because we don't have mechanical computers that are running software. So it's got to be electromechanical, really. And so that's part of what's got to be included. And that's what really enables the software to reach out and touch the hardware, is the electro-pneumatic, electro-hydraulic, electro-machine manipulation of the eventual hardware that does the physical thing.
Yep. Yeah. In your history in the automotive space, which spans many years, as you explained at the beginning, John, what's the one thing that surprises you the most of when you look at that history to where we're at now? Is it, I never thought 15 years ago or even 5 years ago EVs would be as big. I never thought a technology like what Tula has would be real. What's the one thing that sort of sticks out to you that when you look back, you say, yeah, over my career, or at least my first 20 years or whatever it might be, I would have never expected this to happen, or I would have never expected something we've done for now 30 years to now suddenly change, right? What's the one thing that sticks out to you?
I hesitate to say electric vehicles, but, all the way back in the 80s, they were there. There was an electric vehicle, over 100 years ago, right? But I think at that time when we thought about it, and, we all, got out our pad of paper and did a little calc and said, holy cow, it's going to take an incredible battery to try it, so it's not going to happen. So, going back to my, my admiration or excitement about what's happening in the battery space, I would say, yeah, the electrification of mobility, and I would say most of the accomplishment to make that happen, I would say, is probably in the battery space. When you look at power density, either volume or weight power density and durability, okay, it's just nothing like that existed way back when, back in let's say the dark ages of my youth. I would say, smartphones, we take them for granted now, but I think back, I remember when the BlackBerry was amazing. You can send an email from your phone. That's incredible. So I would say, our ability to communicate, yeah, and I would say the connectivity that we all enjoy now through internet, through smartphone, through ability to collaborate, ability to be in a position to, tolerate, survive COVID the way we did. If that would have happened a decade or two earlier, it would have been a different story, I feel anyway. I at least in our company, so we're a software and Cal and IP company, so we didn't have to, we run a couple dynamometers, but I think through COVID we were able to, work at home pretty seamlessly. Whereas obviously, for many, many, many people, it was a catastrophe, of course.
Very good. Well, thank you, John, for your time. Thanks for explaining.
My pleasure.
An interesting technology that you are working on it now, and good luck with it. And Thank you very much for your time.
Many thanks to you, Stephan. My pleasure being with you today.
Thank you.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.